So number 18. Number 18 is a short answer question. And it says, Serena bought some small and large picture frames. She paid $3 for each small picture frame, and she paid $5 for each large picture frame. She bought a total of 10 picture frames, and she paid a total of $36 for all picture frames. There is no sales tax. What is the number of large picture frames that Serena bought? Now, I've seen people try to just figure this out by saying, okay, there's 10 picture frames. What if I make 5 small and 5 large? Well, that doesn't work. And then they just keep experimenting until they find out which one's the right one. The way you should approach this is by using simultaneous equations, which means you pick out values for each. Here's what I mean. So I don't know the amount of small picture frames, and I don't know the amount of large picture frames. So I'm going to pick out a variable to represent the amount of small picture frames. So I'm going to choose X, and that's going to equal the number of small picture frames I have. And for the number of large picture frames, I'm going to choose Y for that. So the number of small picture frames is X, and the number of large picture frames is Y. If I do that, immediately you should notice that if I add X plus Y, or the number of small picture frames, and the number of large picture frames, I come up with the total number of picture frames. Or in the problem, it says the total of she bought a total of 10 picture frames. So X plus Y is going to equal 10. So let me write that out. So X plus Y equals 10. Now, what about this 3 and this 5? Well, that's telling us the cost, right? The cost for the small picture frames. So if I wanted an expression that represented the cost of the small picture frames, I would take 3 and multiply by X, and that would give me the cost of the small picture frames. So let me bring that down and put that in this window here, if I can get the window to line up there. So 3 times X is the cost of the small frames. And what else do we know? Well, the large picture frames cost $5, so 5 times Y, or 5 times the number of large picture frames we have, is going to be the cost of the large picture frames. Right? That also tells us a little bit more, that if we have 3X plus 5Y, or the cost of the small picture frames plus the cost of the large picture frames, we're going to have the total cost. And remember, in the problem they told us she paid a total of $36. So that's the second part of our simultaneous equation, that 3X plus 5Y, well, that equals 36. Well, if I use that X plus 10 and X plus Y equals 10, and along with this 3 plus 5X equals 30, or 5Y equals 36, they're 2 simultaneous equations, and I can solve this by using substitution or elimination, whichever method you use to solve simultaneous equations. I'm going to solve this by elimination, I think, because that's going to be easier here. So I'm going to draw a little line underneath both those, and I'm going to add these 2 equations together and hopefully eliminate something. But I notice if I add these 2, nothing immediately eliminates one another. But let's say I wanted to get rid of, I don't know, the number of large picture frames, right? So what added to 5y would make the y's turn out to be 0. Well, if I multiplied this y by -5, or if that was -5, -5 and +5, they would cancel out. So there's a way I can do that. If I multiply every single term in this second equation here, this x, this y, and this 10 by -5, I would have the -5y to get rid of this 5y. So I'm going to do that right now. I'm going to set that up. So I'm going to multiply this by -5. Bring that down a little bit. Multiply the other by -5. And then I'm going to multiply 10 by -5. So let's write that out. So as long as I multiply everything by -5, this equality remains the same, right? If I had the number 2 equal to 2, if I multiplied both 2 and 2 by 3, 6 would still equal 6, right? So that's basically what I'm doing here, just with a few more numbers. So 10 times -5, what is that? That is -50. So I'm going to replace this value with -50 right here. Okay, let me erase this. Select my little eraser. Alright. So when I add these two things together, well, that's going to be 0. And then 3x minus 5x, that's -2x. Remember, when the signs are different, you're going to subtract and it keeps the sign a larger number. Here, once again, 36 minus 50. Signs are different, so you're going to subtract. 50 minus 36, that's 14. And it takes the sign a larger number, so it's going to be -14. So when I write this all out, it's going to be something like, if I can get it up here, it's going to be -2x plus 0y's, because 5y minus 5y is 0y, and then 36 minus 50, that's -14. So 0 times y, that's 0, and then -2x plus 0, that's going to be -2x. So that leaves me with -2x is equal to -14. Well, what times -2 equals -14? 7. So x, or the number of small frames, is going to equal 7. And if you think about it, in our original equation there were 10 frames altogether. There was 10 picture frames, right? So if I subtracted the number of small picture frames, I'd get the number of large picture frames. So there's 3 large frames altogether. Don't know what I did there, but and that answers the question, right? The question was, what is the number of large picture frames that Serena bought? There are 3 large frames, or Serena bought 3 large frames. So that's number 18.